through 20 years.
So let's say, for example, this is a great example. So let's say I want to figure out what's taking up the most memory on my machine. So you use the key, you go to the command line and you enter this command, top. And here's what it does. I mean, this is it.
Nice.
Yeah, I mean, it's that simple. And this is infinitely customizable too. So you can say, okay, do I want to list, only stuff that's looking at the internet? Do I want to list stuff being run by a certain user? But so the top one of this is called Xorg, which is my graphical user interface, and Chrome. So Chrome, and then I have S-Office, which is Open Office, and that's where I'm running my presentation that we just saw is on. So clearly, those are taking up the most juice on the machine. And then it tells you, percentage of CPU time, percentage of your memory that you're taking up. And so that's how you really, if you want to really squeeze every bit of performance out of your machine, I mean, that's what you can do.
Well, I guess I'm just thinking of the last Windows machine I bought.
Yeah.
Like printers from 10 years ago.
Yeah.
Got the drivers for those printers that are been in the dump for 9 years.
Yeah.
So I don't need that stuff. So
Yeah.
Just depending upon that organization to put cull through their processes, the minimal environments or the minimal programs that should be installed with the release of Linux.
I would say, depending on which some distros really pare it down. I mean, and so right out of the box, like I want to say with Arch Linux, for example, I mean, you install it, it might not even have a graphical user interface on it. All you see is this might. Let's see if I can get this. Hold on a sec. This I might not be able to switch this. Oh, there we go. Nope, it's not going to show up on the screen. Oh, yeah. All you see is, there it is. That's all you would see. And this is really, I mean, what I simply did is, you can log into Linux with as many accounts as you want. So, I can log out. There you go. And I can log in again. And this is on the exact same machine, and I just turned off I didn't turn off, I kind of minimized, if you want to think of it that way, the graphical user interface. And so now I'm just looking at the command line, and if you want to get it back, you can, it'll come up in a second. There's a little bit nicer to look at. But yeah, I mean, you can literally, if you really are, want to be super duper lean and mean about it, yeah, you can, take everything off that you don't want. And when it comes to drivers, and that's another thing. That's another area I think where people sometimes complain about open source software because you can't find drivers for X, Y, and Z. You're dependent on somebody actually making a driver for open source, and that probably is true. But you rarely actually in practice run into a problem. So for example, maybe about 4 months ago, I got a new motherboard for my computer at home just to upgrade it. Pulled out the processor, pulled out the hard drive, unplugged everything, put the new motherboard in, plugged it all back in, booted it up, and Linux said oh, new motherboard, cool. And it booted right up. Windows, I had to uninstall, I had to completely reformat the hard drive and reinstall Windows. It couldn't deal with it. It just couldn't hack it, which I thought was so interesting. Actually, it was just yesterday. I installed a new version of Windows. So, first thing I did, okay, go to Windows Update, and 2 hours later, it was done updating it. It's just amazing. But I don't want to. I mean, I don't. I think it's important, especially because we live in Seattle, not to. To say any one operating system is absolutely guaranteed, better than the other. I mean, they all have advantages and disadvantages. And so I want to stay away from kind of saying, Linux is always better than Windows, or Linux is always better than OS X, because that's absolutely an oversimplification.
Well, the way I'm approaching it is that I think on the part of the lure to come here was that, let's say you want to have a Raspberry Pi operate as a media server, which is kind of my idea right now.
Oh, okay.
So with the version of Linux that I have on the Pi, I have to put another driver on that's particular to external hard drive that I want to use for the media storage.
If it's an external hard drive, probably not. I'm not. Don't quote me on that, but hard drives are so, kind of commodities now.
Yeah. Again, down to the nuts and bolts of it.
Yeah.
Does it have the drivers that I would need to recognize that there is another drive plugged in?
The best way to find out is you find out your drive, Seagate, whatever it is, and you just Google it, and then Linux.
Like Western Digital on Raspberry Pi.
Generally, the drive has the interface that describes like the sector layout, cylinder layout, etc. You don't have to configure any of that stuff.
The best way.
So you should just be able to plug it in and say,
Yeah. Drives are pretty. Usually you think of drives as being pretty straightforward. It's not like a sophisticated kind of, specific piece of hardware that, has a very specific driver. Drives typically, they kind of all work the same.
I'll take your word for it.
No, don't do that. No. Before you go out and spend $200 on a drive.
The internal structure of these different distros is such that a hardware manufacturer can write one driver and have a good chance of it working for everyone?
Usually that's the case, because usually what you're writing for... Okay, so go back to the command line. So this is a great example. This is uname is the command that you get to get basic information about your system. And this shows a couple of interesting basic ways of how the command line works. You start with the command, which is uname. And so if you type the command itself, there, it says this machine is running Linux. And then if you type, can you guys see that well enough, or it's kind of small? Okay. And then if you type, you add a couple options and it'll tell you more information. And so for example, this machine, the kernel, is Linux kernel 3.16. And then a couple other details on that. But and so a hardware vendor that wants to write a driver is going to write it for a specific version of the Linux kernel. And that's what you write your driver for. And so any Linux kernel that's, I'd say roughly close, but it's somewhat modern, should be able to run that driver. So you're not going to have significant distribution-to-distribution differences in drivers. You really should only have one driver. That the distributions, each distro then takes that driver released from the hardware vendor and packages it into its package management system. But otherwise, the underlying software should be the same. I'd be a little surprised if you had to change it too much, if at all.
Question.
Sure.
Would you be willing to give us your email?
Yeah, of course. Yeah. And then, another thing that when you get started out with the command line is, okay, what the hell do I do? I have no idea. I don't know how to do anything. And kind of one of the very basic commands is called man, which stands for manual. And so if you want to get information on any Linux command, let's say uname, what I just used. It has the one of these pages that comes up, and this is basically at the most fundamental level your manual. So the command uname, well, print information about the system, and then you get all these different things that you can print: the processor, the machine, the kernel version, all this stuff, and that's what it's an example of how the basic functions of Linux are very simple, but then they're highly customizable. And so you can, write out all sorts of information. Another one, and so you mentioned grep, and that's a let me see. Oh, CD stands for change directory. So that's how I move up and down in the directory tree. So, for example, I have a software project I'm working on now called Xenotic. Oops. So there's a lot of source code. There are probably, I think, at least 100,000 lines of code in this. So how do I find a particular function that I'm interested in? Grep. So the way I do it is say, okay, I want it to search recursively through all the directories that are below it, and I want it to look for, I want it to be case insensitive. I want it to look for something called anything with the word haptic comes in, because that's what I'm working on now. And then there it goes. And it'll literally search through, this entire, all these lines of code, looking for any mention, of the word haptic.
What did that in the end have to do?
That means the present directory, like the current directory, and so that means start here, and then kind of work your way down. And this is taking, usually it's faster than this. Let's try. There it goes. And so this gives you, in all the gory detail, all the places where that word appears. And
well, that's actually looking in the source code.
Oh, you bet. Yeah.
Oh, wow.
So here's the other absolutely fundamental command, ls, which just means list. This gives you a list of everything that's in the directory. And then, here's another great example. Let's say I want more information, ls/long. That gives me this is the size in bytes, the user who owns it, the group that owns it, and then the date that it was created, and then its name. And one thing I think, this is another good example of one of the fundamental characteristics of Linux is these little letters in the front. Well, what this means, these are the permissions on the file. This is one of the central security features of Linux. So these are in groups of 3. So the first group of 3 means the user who owns it, in other words, this person, has read or write access. That means the owner of the file can read the file or edit it. The owner of the file cannot actually execute it. I could if I wanted to. It wouldn't do anything, but I could change that. The middle one is for the group, and then this one is for everyone. So for very sensitive files, you will have very tight permissions on them. But every single file in the entire system has this characteristic, and so it'll tell you, who has permission to read it, who has permission to write, to edit it, and who has permission to execute it. And that's just a fundamental concept in Linux. And so let's say, for example, I wanted to get. Let's say I want to know how many files are in this directory. So how would I do that? So, well, this is so much of the work that you do in Linux is just like this. All right, well, that last command I typed listed them all out, one on each line. Well, why don't I just count the lines? But I don't want to count thousands of lines. And so we do it like this. So that'll print what we just saw, right? There. But now I use something that's called a pipe. That's what that little vertical line means. And that means that you're literally hooking these different programs together. So the output of one is going to be the input of the next one. So the output of this one, I'm going to feed into the input of another program called word count. And then I want word count to work in line mode. So it literally counts the lines. I have 285 files. And so let's say, so how did I know that? I went to Google and I said, count in Linux, display number of files in a directory. And somebody said, oh, just do this. And I said, well, that's kind of cool. I wonder what else word count can do. Okay. So it prints the new lines, or the words, or the byte counts for every file. And then it gives you its description here, how you use it. And then
so you can see the changes you made since last.
Changes you want to use, you use diff. So diff is a great tool. So I don't have a good. Let's do the diff. I'm trying to. 2 files that are pretty similar. That would be interesting to look at. Tell you what. Let's. Okay. Zone C is copy. CP is copy. So I'm going to copy this file zone C to zone C temp. Okay? And so now you'll see I made a copy of this file called zone C temp. Same size, 30K. Everything else about it is the same except it was created, May 31st at 4:04 p.m. So now I'm going to open zone C temp, And it doesn't look like much, but this is actually a very, very powerful editor. And this is a whole other topic that we can talk about.
Which editor?
This is called Emacs. Yeah, but this is, I think that we spent a lot of time going down that road.
No, I'm just curious on different text editors are in use and which are reasonable and easy to use versus the complex ones, and pick something. Nano?
Nano is the easiest, yeah. Nano is standard. Yeah, so Nano, Nano is probably the, so I'm going to save that. Okay, so that's, save file, yes. Okay, so now we're going to go diff. So zone C and zone C temp. There it is, that's the difference.
Take that in upper keys and show them what happens.
So Linux is case sensitive. So if we try to do that diff, in uppercase, command not found. Linux is case sensitive. That's very important. So when you're getting started out, that's one of the very important things to keep in mind. Linux won't allow spaces in file names, and so what people will typically do is something like that. But at any rate, so this diff thing is kind of cool. I mean, you can, I've never really played around with it much, but I mean, it's kind of interesting. So, okay, we can report only when lines differ. So we can flip it around so it only reports the lines that are the same. So it can, it outputs the number of, I guess that's the number of differences in the file. Outputs it in 2 columns, so that's kind of cool. So we'll do the same command, but we'll use the Y option, and look at that. Mm-hmm. So it literally gives, yeah, it's not a great, yeah, there it goes, that's pretty good.
Right through less.
Yeah, so another example of a pipe. So I'm going to pipe the output of diff into a little utility called less. And the only thing that less does is it lets you move up and down. And so here, here's the only difference here between the 2 files. And this is just kind of, these are kind of random examples of how you can use the operating system, but they're also very realistic examples. I think you can do this in color too. Let's see if we can do it in color. Not sure about that. Nope, didn't like that. Wait, why did I not like that? Huh. At any rate, so text editors. I mean, if you want to talk about like the full-blown, call it the somewhat like Microsoft Word text editor. It's called LibreOffice or OpenOffice. I'm not exactly sure what the difference are between those. But this is it. So I mean, this is your normal. So let's say we want a new text document. There you go. It's your standard word processor. But it's graphical. It's tons of features in it.
And a lot of junk behind it.
Yeah, a lot of. When I usually take notes, which I do a lot. With at work, I usually am doing them. I'm usually doing them here. And when you think about it, why do I need a huge word processor just to take some lines of text? There are a lot of advantages to doing it simply. First of all, it's a tiny file. Second of all, it's searchable on the entire computer. I can search through every single file on the computer, and it'll find that text. And so the very most basic text editor on Linux is called Nano. And this is what it looks like. And Nano doesn't do much, but it kind of works, and it's as the name implies, it's tiny. And so if I want to quit it,
to me, that it looks a lot like old WordStar does.
Yeah, I mean, it says, do I want to save it? No. Okay.
Yeah, I guess the way I'm approaching the text editor is that I'm also learning Python.
Oh yeah, okay, yeah.
I'm also learning
Python is
Node.js.
Yeah.
And is it a dream to try and standardize on using one text editor that will fit many different needs?
The way, okay, so for writing code, there are a lot of people, particularly kind of in the open source community, that I would describe as kind of like me, that like to write code in a simple text editor that has a lot of features in it. And the two major ones are Emacs and Vim. And the debate is, it's kind of like debating religion, you know. I mean, yeah, okay, two religions, I mean, they're probably never going to, you have adherence to both, and that's fine. I like Emacs, but maybe that's just because I started with it. So let me give you a concrete example. This is another project I'm working with, have been working on. This is an automatic identification of bird calls. This is a machine learning application. It's implemented in Python. So I'm going to give you some of the, let's see, let's get a Python, here we go. Let's do small, so I'm going to use Emacs, and let's look at some code. So there's Python. This is what I write code in. So you get these nice colors. There's just auto completion. There's a debugger that's built right into it.
Syntax checking.
Yeah, it does syntax checking. And like this is another interesting example. I mean, this is machine learning. It's very processor intensive. If I wanted to do this on the cloud, how would I, I could use this exact same program on the cloud. I just remote into it and use the exact same thing. And this looks exactly like this. And it's fast. You saw how long it took to boot up. It's instantaneous. It's just a great tool for for writing code. But you look at it at first. Most people look at this and you're like, oh, it's just a bunch of colored text. And what's so great about that compared to my big, gorgeous integrated development environment, Visual Studio, Eclipse. And I've worked with both of them, particularly Eclipse, and this is what I prefer. But again, I think it's a largely personal preference. Use the right tool for the right job. But you can do a lot of stuff with Emacs. Emacs does take a little bit of time to learn. It's really, this thing was written by a bunch of software geeks who don't want to move their hands. And so there's no mouse, and I do everything from, and as a consequence, there are a bunch of really kind of funky commands that involve hitting the control key and the shift key and the alt key all at the same time, and it takes a little bit of time to learn, but once you learn it, if you invest that initial kind of unpleasantness in learning these funky commands, it can become extremely fast. Like you can page through text. Here, I want to go to the beginning of the file, end of the file, and then you can go word by word. I can go to the end of the line, beginning of the line, cut and paste, all the standard stuff, and I never move my hands. And so it's a very efficient, also kind of ergonomic way of writing code. And so that's Emacs. But again, steep learning curve, just be prepared for that. So let's take a look at the actual desktop. And take a look at what that looks like. Because after all, this is somewhere behind here, all my terminal windows, I actually do have the desktop. There's a spread, that's a soup broth recipe. Some notes. There you go. So this is it. This is actually the LXD desktop. And it looks pretty nice. It's got kind of, somebody coming from Windows or OS X wouldn't completely be lost, coming to something like this. You've got the equivalent of your start menu down here, where you can launch your programs. If you want to turn the machine off, you go down here and, you hit log out, and then, shut down, log out, suspend. And so this is usually how most people get, kind of get started with something that they're very used to. And there are a couple options, as I mentioned, a couple options out there for Linux graphical desktop environments. Here, let's Google it. Linux graphical desktop environment. And so here you go. 8 different. First hit. Here you go. 8 different types of. You can choose them. And if you don't like one, you can get another one, or you can customize it. So, Unity, it's the one that ships with Ubuntu. There's GNOME, that's what I talked about before. KDE, which I mentioned before. XFCE, which is lightweight. And then the one I like, LXDE, super duper lightweight. It's focused on being as lightweight as possible, and especially designed for older computers. But I like it because it's just snappy, you don't have to wait around for that little bar to go across the screen, So
Any of those have better or easier to install than install software?
I'd say they're probably about the same. I'd say you're going to have a couple hiccups. Usually, the thing about Linux, you have to understand, like when you first try to get something to work, you typically are going to have maybe a couple hiccups. But then somebody else went through this thing and wrote about how they did it, and so you're able to figure it out usually very quickly. And so how would you do that? Like, let's say you wanted to install, what was the one? What do we like? XFCE.
Sure.
What was the other? Or what was it? Unity? That was well, anyway. So let's see. So in the Debian repositories, do I have to pause?